Down again. Now you should be able to hear me. Let's go again. So, assessment. So sorry for the technical issues. So the assessment. What we are doing is that we are basically have the exam, which is 30% of the marks, and we will be putting some example exam on Brightspace. I haven't done that yet. We've been too busy with helping people with the assignment. For those people who have extensions, we will continue helping that, but hopefully we have a bit of time to actually put up some example questions into Brightspace so that you can take some test exams with the proviso that, well, for the test exam we can let you know how many you got right. That is not necessarily the mark. We will look at how things are, how it's done to actually set a mark rather than just taking a flat percentage. Because we haven't done multiple choice for this unit at all yet. So that's what I'm going to do. Then the topics. So this is an overview of all the topics that we have gone through this year, mainly only the theory ones. Let's put some light on. That should help a little bit with the visualization. So these are theory ones. A few of them I've switched from practical to theory, etc. But we're looking at the stuff that might be relevant for your exam. A tiny bit of clarifications were added here as well, but not that much. So to start, values, variables, pointers, and lifetimes. I'll try to go through this reasonably quick because I'm not having that much time. A lot to go through. There's 95 slides, my system says. So, values and variables. So, unlike math, in computing, when we have a variable, that is actually a storage location where we actually keep that value there. Whereas a value is 2 or 5 or etc. and it doesn't matter where you store it, it's the same value. The storage location is different. And it's helpful to understand that when you have a variable, you're talking about storage locations. And especially when you have a variable, so one that can change. If you have a final variable, or Kotlin calls it a val or value, then that change thing goes away, not because it's not a storage location, but because it is forbidden to change. So at that point, you can actually treat it as if it was a value. With one additional proviso, that is that your actual program cannot, so that if things inside your value can change, that is still changeable. Whereas in math, a value is that and it can never change. So if you do not have an immutable type, then still the insides of your value can still change. They basically, a compound value in Java or Kotlin is a collection of storage locations, effectively. It exposes named storage locations as the inside of that thing. So that is how that works. So when you have a variable or a name in programming, you have a limited lifetime. It's limited by the scope, and in this case we call that a lexical scope. So look at your program and see, okay, which is the scope, which is the set of curlies in which this has been defined. And outside that block, the name just does not exist. Or it falls back to another thing with the same name. And we call, if you do that, that's called shadowing. Not a very good idea in general. Sometimes it's okay, but you need to be very careful that it doesn't become confusing. But so a name that falls out of scope disappears. The value attached to that may not. There's another slight point that there is also something called temporary conceptually. So if you have a function and it returns a value and then you're adding 1 to that, that return value gets kind of a temporary storage location, and as long as you're in that expression, you're still using that location is still there. It is very temporary. As soon as you have done the addition, it's gone. Let's not go over the mechanisms by which that works, but that's what it's doing. So when you have your values, they live basically as long as there is a storage location for them. In particular, if you have a garbage collected one, there's 2 storage locations. Effectively, we have the reference that points to the actual location of that object. As long as there is something pointing to that thing, it says, okay, there is a way of getting at it, therefore it lives. And if you do not have pointers or references, you basically only have 1 storage location. So that's where pointers come in, and they are very important when you look at objects and instances. So a Java reference or Kotlin reference is effectively a pointer underwater. It hides away the fact that it's a memory address, and on the JVM it isn't necessarily a memory address. That's all up to the JVM. You cannot get at the raw number, but it is a way of looking at a particular space in memory where that particular object has been defined. And you want to make sure that, of course, it points to a valid location. So a reference is that, and then null is a special value that makes it, that effectively cheats a little bit on the definition, because if you compare with null, you are comparing with the pointer value rather than anything else. But because null is only useful in that context, it doesn't matter. So references and pointers allow you to say, okay, there's multiple names for the same value, for the same memory location in which that value has been defined. So there's multiple ways of pointing at that. So multiple attributes could hold the reference to the same object. You can pass it along, etc. And when you're looking at UIs, this is really important, because if you want to, say, get something out of a text box, you want to go that text box with that text that is displayed there. You don't want to make a copy of it and then you update the text and it doesn't work, or it gets an empty text field and you can't get the text out of it. No, you want that particular one, you want it to be updated in the UI. Another point that we started out with is naming. So how do we make good code? Well, we need to make sure that our code is really readable. Make sure that our code is structured well. So you put it into packages and files to group stuff so that it's easy to find what is where. You can put stuff into classes or into functions. And you even look at your statement. Are your statements easy to understand? Maybe I need to extract a variable so that the statement becomes clear because the variable name conveys its meaning. You put too much math into one big blob, then it becomes hard to understand. If you have a variable that you're only using in one place, it is peanuts for a compiler to say, okay, actually, I'm not going to use that variable. I'm just going to calculate the value and immediately use it. That is very easy to optimize. So leave that to the optimizer and you write readable code that is easy to understand by the optimizer as well as people. And in a way, when we look at sentences, so what you want to do is, in a way, you want to express the idea of your algorithm in a clear way. Come back to algorithms. So in any case, when you want to make code, make sure that you have clear names that communicate a purpose. If you have a variable called temp, or you have a variable called row means it's a row. If you compare a row with a column, we know it's wrong. Or a row with a width, we know that that is maybe wrong or maybe not, but we can have a meaning. We can intuitively think, okay, there's something dodgy there. So one of the things you also want to do is keep your functions concise, make them do one thing, use empty lines in between them like you would paragraphs in a piece of prose. Try to keep your code simple and organize stuff in coherent files. And one in particular important thing is that when you have code, try to make sure that when people read code and they think, I think I know what that does, that should be correct. You use conventions to help that intuition along, and you make also design your interfaces such that it is hard to misuse the API, to make a mistake. And in particular, one of the things that helps is like if you have a bit of functionality that is a bit weird, and that could even be something like is even or is odd for an integer. If you make a function of that, then it's very easy then to verify that the function is correct because you know exactly here what it needs to do. And then when you use that function, the code is very clear. Oh, I'm checking that it is an odd number, an odd y coordinate. Okay, that means my label is horizontal. So you could have actually, even then you could create a function that for a particular game says, okay, is this a horizontal line or is it a vertical line? And that's okay, it's horizontal if it's an even line. When you have that code, you don't even need a comment to explain what is going on because it's there. By the way, one of the things in that context, when you have an else clause and it's a bit further away from the if, you may want to have a comment to say what it does. What you do not want to do is have an else if and then it's just the inversion of the condition of the if statement. Because it's very easy to get them out of sync and then nothing happens. You always want an otherwise option. Version control. So the idea of version control is that we want to keep our code well organized. We want to help collaboration. We want to keep track of versions. We want to be able to go back if we accidentally delete something. I believe one of you had that happening. Or if you make a mistake or if you do an experiment, etc. So you can use it to keep track of versions. You can go back to previous versions. You can use it to manage releases. In particular, if you look at branches, you can say, okay, you have a released version, version 2 or version 3, and then, oh, there's a bug. You go back to that version. You just fix that bug in there, and then you have a bug fix. You might then also take that bug fix and put that in your main development branch, often called a master branch, and you basically work in parallel. But you do not necessarily want to release your current work in progress just because there's a bug that is hitting people with the back things. So that's what you want to think about. Then there's a lot of terminology that you want to look at. And by the way, please make sure that you still look at the original slides. This is a summary, it's not everything. So we have in version control, we have a repository that stores all the change information, all the information of the version control things. You cannot directly edit this. I mean, there are some bits you can, but the database itself you normally do not edit by hand. In Git, that is stored in the .git folder. You know, Git is a distributed version control, so every place where you have a Git, you also have a repository. Then there's the term working copy. So this is the actual files that you edit, that you work. So this is your work in. In Git, your repository is the .git folder inside a working copy. So every working copy has its own repository attached to it. But a working copy is just one version. So you can even switch between versions using the Git tools to go, okay, I want my working copy to be this version, to be that version, to be that version, etc. That also comes to the idea of the checkout operation, where you basically get a particular version out of your repository. Often what you do is just, rather than say I want version with a particular identifier, I want the master one. That uses the master tag that is automatically set to the latest version, or the master branch name. So you can get the latest version of the master branch from the repository. Because we have a then there is, so that is there's another thing, is like you often want, if you have a non-distributed system, checking out a version means often that you are going to actually go to the repository and go get that version into a new working copy. Updating says, okay, just give me the latest changes. And then committed means that I send a set of changes to the repository. Depending on the system, you need to explicitly add items to your working copy before you can send them. Most of the systems do that, because there's also files that you do not want in your version control system. Git is particularly pedantic in that every change needs to be added. When you look at Android Studio or IntelliJ, they will actually help you with making this and will add things automatically for you. So you don't need to bother about that too much. So that is what committing is. But have a look further, because some of this may be very well coming up in the exam. So the exam will have the 30 questions take a rather scattershot approach. They will not look at, oh, these are the core topics. They will look at all the topics and have a few questions about each of them. There is a randomization. There is many more questions than you will be getting, but they will cover all the topics there that are not practice topics. They will not ask you about anything particularly Android specific, perhaps as an example, but not more than that. So VCS operations, we had a number of them. Add a file to the thing, ignoring a file, very important, the ability to ignore certain files. In Git, you do that just with the .gitignore file. You can say, okay, don't tell me about changes in this file. Don't offer me to add this to the repository. So when you look at the status of your repository, it says, okay, yeah, okay, these files are changed. The ignored files, it will just not display anything about them. And yes, you can also delete files from the version control system. However, that just deletes them from the branch, from the current working copy. And then when you commit it, it will be deleted from that version, not from history whatsoever. The idea of version control is that you do not rewrite history. If you delete a file, it is deleted. Now, there are some ways in which you can actually rewrite history, but that's a whole other ballpark. Although in Git, there is one way which you use that often, is when it do something like called rebasing. But that is more if you're working with someone else's stuff and you don't want to have your changes be really, really complex, but you want to make your changes fit very well to their code. And in a distributed versions control system, we have the clone thing. So cloning is GitHub's version, or Git's version of creating your own version of that repository. So you get all the change information from that repository, and then you can work on that locally. You can also clone a local working copy to another working copy, and then you can work with that. It also means you need to push to a remote repository or pull from a remote repository. And while you normally just have one single remote that you're working on, you can actually have multiple remotes that you work with concurrently. Coding tools. So it is important for you to know the tools that you're using to write your code. Those are coding tools. And one of the key part of that is a build system like Gradle, which takes all the input source, that is your sources, but also other things like images and those XML files and various other things, and it creates the final program. In Android's case, that would be an APK file. There's a lot of things that need to happen to make that work, but the rules for making that work are actually the same for all Android applications. So rather than you having to do that all by hand, there is an Android plugin for Gradle that will actually give you the code and tells you to say, okay, I want to, it will just build it all for you and knows how to do this correctly, and you just configure the bits that you need. But there's a lot of things going on underwater. An interesting thing of modern build systems that they are often able to automatically download your dependencies. That makes your development a little bit easier. There's some limitations to that in some contexts, but let's not go there. They also are, because they're basically automation tools, they know all the dependencies, so they are very easy. They're in a very good position to run your tests, because they have all the dependencies there. They might download, they know where they live, so they can easily run your test code. And indeed, build tools have quite often, or since many times, had the ability to say, okay, I rather than build my final build, I want to actually run the test code. And you can do that. In Gradle's case, it would be Gradle W check. And so there's also some other convenience operations that it can do. So it can actually also be used to run your application as a test version, because in the you don't want your end users have to use Gradle just to run your application. And you can also install it. Like for Android, there's a Gradle task called install debug that installs the debug APK on the single attached Android device with debugging enabled. So either an emulator or a real phone. But if there's two of them, it won't work, or it might install onto both. I haven't checked that. So the development tools that you're working with. So we have Android Studio IntelliJ. It's an editor. It does not run your code. It is just a very, very fancy, very featureful, glorified editor. And it provides a UI to many of the other things. So it is a user interface. It doesn't do the building of your code. It doesn't do the running. And your stuff does exist outside of Android Studio. Very important to realize. Your editor is just that, an editor. Those text files, you can open them with Notepad. Editing them with Notepad will work technically fine. It's just a pain in the ass because Notepad isn't really that powerful as a as a code editor, and it doesn't help you with indentation and stuff like that. But you can use any editor. There's a built-in editor in the GitHub interface. You could edit your code online in GitHub and actually make that work. So Git is your revision control system. I didn't put that here, but GitHub is a host for repositories. So it's a company owned by Microsoft now that hosts Git repositories, where you can host your repository in a central location so that you can do collaboration and sharing and all that stuff, rather than having to rely on having that on your local machine only. And it has also other kind of nice things, like a way of looking at your revision repository. Like I said, it has an actual editor built in for the quick edits and many other things. But Git is a revision control, and GitHub provides you the ability to have Git repositories. Gradle is our build system. Then we got ADB, or Android Debug Bridge. This is a tool that lives both on the phone or emulator as well as on your computer, and it allows interacting in a debugging fashion with your phones or emulator. So it allows the debugging to work, it allows the uploading of packages to work, etc. That's ADB. Then there's AAPT, which is the Android packaging tool. I forgot what the abbreviation is. Basically, it creates, there's a lot of things going on, but what it does, it packages all your images, it packages it transforms your class files into Dalvik bytecode, because Android doesn't quite use the JVM. It has its own virtual machine, but it translates from Java class files to its own virtual machines based instructions, and then packages that all up into one application, all done by the AAPT tool. Then there is, because Gradle is just a build system, it doesn't actually build anything. It delegates the actual compilation to either a Java compiler or a Kotlin compiler. In this case, Kotlin C. And it that creates your class files. Gradle kind of integrates that, and it tries to work with it smartly. One of the reasons that Gradle or that Android development uses so much memory is because when Gradle runs a Kotlin compiler, it actually runs it in a persistent mode that keeps it in memory even if you're not using it, because it makes it much faster to start it up. So it makes building your code after you made a few changes very, very easy to do and very fast at the cost of memory. Memory from a developer perspective is cheap. From a company employing developers perspective, it's cheap. It's only an hour of developer time, so to speak, to give someone a decent amount of memory. And then the emulator, it's just a virtual phone. It works like a phone, but of course you can use it to test your applications in more variable circumstances than you would if you had a real phone. And of course, when you develop in a professional setting, you still want to test on actual phones as well, in particular because actual phones also come with actual implementation bugs all of their own. Samsung is very well known for that. Then we have debugging. So a key tool in the development is the debugger. In the end of the day, a debugger is just a tool that allows you to inspect the running of your program by allowing you to pause the execution, either through breakpoints or other things. So there's different kind of breakpoints, but the idea is you allow to pause the execution, then you can then query various elements of the state of your application. You can see, okay, is this what is expected? And it actually allows you to modify the state either by changing values directly or by running code. What it doesn't do is fix your code for you. Very common misconception I've seen in exams. No, debuggers do not fix your code. They help you interrogate what the state of your program is. So they are basically querying values is the steroid version of print lines. You can actually go in and look at it. It is also why often it's very helpful the toString function for your data, so that when you're debugging, you can actually see a textual representation of the state of your object. But even if there's no toString, you can actually define in the debugger your own toString functions for that particular type that get used instead. The debugger has a lot of powerful tools, and I won't go into this, but if you're interested, go and explore all the interesting things you can do with the debugger and become a debugging expert. The key parts, though, that you do need to know is the idea of being able to go step over, that goes to the next line of code, step into, that goes into the next function on this line, so it goes actually into function calls, where step over doesn't. IntelliJ or Android Studio has a smart step into, so you can say, okay, there's a number of functions on this line that I want to go into. Like often you don't really want to go into a trivial getter. You know it's just a getter. It's not doing anything interesting. You're interested in the function that's being called with the value that was returned by the getter. So, and there are indeed also ways of filtering what it may or may not step into. Step out. Sometimes you say, okay, this function, yes, I know this is correct. I just want to go where this was called from. So there's step out. Of course, you have breakpoints. You can also in Android Studio now click on a line number, and that will bring you execute until you hit that line number or another breakpoint. Breakpoints can be a line breakpoint. You can have function breakpoints, so anytime that function is called. You can also set breakpoints on exceptions or even on changes of values. Those are all more advanced. And you can use a breakpoint to even say, okay, automatically run a command like print some value and then even continue afterwards. A breakpoint doesn't actually, for the debugger, have to stop it in the UI. It stops the execution, but then if you say, okay, continue immediately, it will continue as fast as your computer can then do what it needs to do and continue. A cool trick there is also you can have a breakpoint conditionable on having hit another breakpoint, so you can basically hit a breakpoint only if you came from a certain path to get there. Because one of the problems with debugging is that you have a breakpoint that you're hitting a lot of false positives. So you're hitting the breakpoint 20 times before you get to the actual bug. Then for looking at the state, there is the watch expression, so you can specify expressions that you want to be evaluated. You can also look at the local variables that are visible here and there. Then closures and lambdas. One of the features that Kotlin adds, but Java now has also added, and many languages are adding it if they haven't already, is the idea of lambdas. And lambdas are partly from the idea of first-class functions. So in Kotlin, functions are mostly first class. It's not a fully functional language, but you basically can treat functions as types and values. So there's a function type, there's a function value. The function type is basically its interface. What are its parameters? What does it return? The name doesn't matter, but you want to be able to say, okay, I need a function here that has these parameters and these return types. When you have that, it becomes first class. And if you can then say, okay, I want to have a first class function, you may want to be able to say, I need to give it a name, have a function name. But sometimes when you need a function only in one place, it is nice to be able to have a function literal. Like you can just put a number in your code rather than having to define a constant that has that number and then use it. By the way, that constant can be really important because random numbers become very hard to understand what they mean. But if you had to do that for text messages in, say, an error into an exception, you don't really want to have it have to be a constant all the time just to define it and only use it in that other place. But if you use numbers that have a particular meaning, a constant allows you to give it a name that makes what is going on much more understandable. Anyway, you can have a literal function. How do you do that? Well, you call this operator, or function, which is a lambda that takes its parameters and makes it into a function. And it returns that function as a value that you can then assign to any variable or storage location, so parameter, attribute, etc. Local. And when you have the ability to do that, you can do some quite powerful programming things. In particular, certain kind of problems become much easier to express, much more concise to express. So a lambda is a function that creates a function. Effectively, it's a syntax for creating inline functions. In many languages, including Kotlin, what is created actually is not so much a function as something called a closure. The difference between a function and a closure is that a closure allows you to capture values out of the context in which the lambda function was called. So you're basically allowed to put data with this function and packaging it up together, and when it's called, that data is available to the implementation of that lambda function. Whereas you have a pure function, it can only work on its parameters and have a return value. The closure can have reference to the parameters it was given. So Kotlin creates something called a closure. It closes in those values, it captures them. There's one limitation to working on the JVM or the Android runtime, that it doesn't do. So normally inlining functions, so taking your code of your function and putting it inside the caller, so the callee's code is just copied into the caller, so that you don't need the jumping into that function going back. That is normally done by not done by the compiler on JVM language, but by the virtual machine runtime, the Java virtual machine or the Android runtime, because they have more knowledge to be able to do that. And if you don't do the inlining by hand, they can actually decide whether or not it's a good idea, because sometimes it isn't. And the more you know about the execution context, the better you can optimize. Disadvantage, of course, is that if you are very close to the execution context, you might have a user waiting for you to do the optimization. That is the ahead of time or just in time compilation dichotomy. In any case, there are some cases where we know that inlining really needs to be done by the compiler. And in particular, there are some features that Kotlin can have because it does compiler level inlining. So two of them in particular are the non-local returns. So you can basically, inside your lambda block, you can have a return, and that return returns from the function that called the lambda or created the lambda. And that's a very powerful construct, but that means that the function that, if you have a function that takes a lambda parameter and then that lambda parameter returns through that function to the function that was calling this function, and that's like what your run and your let and your apply, etc. do. You basically pass through that function. To make that work, you need to be able to basically go into the guts of that function. And if it's an inline one, that function just disappears, and the outer function, the one that you want to actually return from, contains the code of the thing, and then the lambda also gets inlined. And as such, you just don't have any function calls left over, and non-local returns actually work. And the advantage there is that it can allow you to make your code look like a control structure. And it's a very powerful thing to be able to do. And Kotlin uses that heavily, because you can create your own control structures like the use. So in Java, you have the try with resources concept, where if once you finish that block, it will automatically close your file. In Kotlin, you can actually do that at library level with the use function. You can implement your own one and make it work exactly the same. Do this wrapping behavior and automatic closing behavior, but without having to have language support for that, a specific language support. Another part where inlining is needed is if you want to do reified type parameters. Basically, you probably know, JVM uses type erasure, but the compiler knows the types, and if you have a function that is inline, you can say, okay, this is the type parameter, make it explicit, allow me to reference this inside this inline, because inlining happens during compilation, so the type has not been erased yet. You can access that type and do whatever you want with it, including getting the class object belonging to that. So you can do a little bit of poor man's reification. Look at that lecture if you for more information on that. So there are some common functions in Kotlin that you probably want to know: run, apply, with, let, also, and the use one. The use is the one that I just talked about, which does automatic closing on completion. But it also helps to understand the concept. So I will not ask you to exactly what does which one do, but you want to have a look at how they work. So this is, for example, how run works. So run function takes a lambda parameter. So the curly here defines a lambda. Let's see. So this curly here defines the lambda, and we print our line. So this calls print line, and it returns. And then there's the 7. This is the last expression. So a lambda will actually, the value of the lambda will be the value of the last element, unless it has sufficient type information to know that it is unit, in which case the return of the lambda might be unit. In this case, so the value of x becomes 7 here, and it prints 7 as well. So, and this particular run does not necessarily take a receiver. You can have it. It might have the receiver, which is the an outer class in which context it lives, but run exists without a receiver as well. Data structures and algorithms. So when we look at coding or programming, a key part of that is designing algorithms. It's about solving problems through computer code. And there are two parts of doing that. There is, generally you need to have some data to be able to actually keep track of where you are, what you are doing. The way that you look at that is called a data structure. How do you store the data related to what you're doing? The algorithm specifies the behavior. And a key part of programming, especially the slightly more advanced one, is algorithms and algorithm design. And yes, this is tricky, but it is an important skill to develop, and it's something you need to practice. That's the only way you get to do it. But an algorithm is say, okay, let's say, okay, it can be as simple as, okay, take all these lines, are they all drawn? Obviously that's a very simple one, and for each the all function you can use the Kotlin default algorithm, or you can loop through every element, and as soon as you find the element that is false, return the function, because then you know that it's not true. You could calculate it all the way through, but that is actually taking more time than you need, because as soon as you find the first element for which the value is not true, you will know that it's not true. But your algorithms always work on data, and the way that it is structured also influences the way that your algorithm works. Or your algorithm function, the way your algorithm functions determines how you have to do your data structure, how you have to design your data structure. So looking at your problem and say, okay, how can I structure this? How can I have data for this? Is a very important skill that you hopefully also exercised in the assignment. And it's like where we have these matrices. Okay, what is the best way of doing it? And there's different trade-offs sometimes. And a sparse matrix particular was one of those, where they say, okay, I have this rectangle, but there's some values that are not valid. Okay, how am I dealing with that? I can just add the values that are invalid and skip them somehow, but in a way I just want to, when I want to look at all my lines, I don't want to be bothered about the invalid ones. I want to ignore them. So what do? I create a function that just says, or a structure that allows me to add a function that says they are valid or not. And if they're not valid, I'm ignoring them, and otherwise I'm using them. And because I'm ignoring them, I don't need to initialize them, because their storage space, their storage location exists, but they're not accessible anyway. So a data structure is a conceptual concept of what the data looks like. You normally want to provide an actual implementation. And one of the core aspects that people kind of forget is that many data structures are a collection of types that relate to each other, work together to implement something, rather than a single type. Like in our assignment, the dots and box game and the line and the box classes are all working together to make things work. Same thing like the player, computer player, and human player. They are related. They work together in a sealed class anyway, but they work together to make things work, and they are also, of course, related to the dots and box game because it works with players, but they are not necessarily part of the same data structure. An algorithm is basically the steps you take, goes hand in hand with your data structure, and creating them is a key skill. One of the elements that I would say that I would recommend everyone, and I can't repeat this enough, is when you are a beginner, and most of you are a beginner, separate designing the algorithm from writing the algorithm. What do I mean? There's at least two ways that you need to think about when you're writing an algorithm. You're first thinking about, okay, what happens? A very good way of doing that is actually to put the computer away and take pen and paper or make props. A deck of cards can be very helpful if you want to look at how do I sort something. Well, you can make up your ordering of your cards and then just do some sorting. Okay, if I do this, if I do that, how does that work? Does it work correctly, etc. So that's what you want to do. You might want to write down in pseudocode or in your comments what are the key parts you need to do, and then you write them. Key part there is also, even if you write your code and you have, say, okay, I need a functionality here, that would be something that I would put in a function. It's a bit complex. Put it somewhere else so this part can be clear and understandable, and that part can then focus only on that. Don't start immediately when I need this functionality. Oh, I need to write that now. No, you don't need to write that now. You just write the thing with the parameters you think you need. Again, some experience helps with that. And then write that function and then update the thing if you needed to change the parameters. But don't move from all over the place, because you will just not be able to handle the complexity. Key other part of programming, and part of where we want abstraction in programming, is the idea of separating complexity. So how do you create a very complex program? By layering your complexity, by isolating areas of complexity so that you only look at that one at that particular time and something else at a different time. There are some common data structures that you should know about. So very, very common storage. So there's the array list, which is basically, the idea is like you have an array that has some storage locations. It has a size parameter, how many values are actually in use, and when you need to add a value to this variable size list, basically it just adds it to the next free location and updates the size parameter. So yes, getting an element is simply going over a particular index very fast, and that's how that works. And if you have integers, you can even ignore resetting the values that you're not using. If you're using objects, you probably want to set stuff to null if it's been deleted, because because otherwise your garbage collector can't pick up the element yet, because it doesn't know that logically the value is not used, but practically it actually still is. Good way of having a memory leak is having an inaccessible value. still exist. And it's accessible to the JVM, obviously. And there's the structure called a linked list. So basically the idea where you have one element point to the next, point to the next, point to the next. It's a very old computing structure. It actually has some serious drawbacks in a modern CPU. Basically, modern CPUs, they use a lot of prediction to be able to execute a code fast, and they use a lot of caching. Kind of say, okay, if it's close together, I'm likely going to read it close together. Thereby, linked lists can be much, much slower than array lists, but you still find them, and there are still cases where they are very useful, or where you need to have multiple things. So you look at an ordered hash set or a linked hash set in JVM that uses a linked list on top of a hash set to maintain order. In which case, yeah, you can't put them in the same thing because that just doesn't work. A hash set is the idea where you have keys and values, but your keys, if your keys are complex, if they're not just integer indices, you need to somehow be able to, and they are not contiguous, you need to be able to somehow have some reasonably compact data structure to store your values, that you can find them based on your key in a fast way. That's what a hash map does. Basically, it takes a number that you calculate from your key. That number you then use as an index into an array, and then you have a link. And every array is basically kind of starting point of a linked list to actually have the actual data. It could be an order, it could be an array list or something like that, with all the values with that particular key. Okay, there's my mouse. So we have a key here, and then there's all the values or these values. And one thing that you need to realize there is if you have a bad hash function, you got all the elements in one thing and you lose the benefit of a hash table, and it becomes much worse than a regular list. So what is it good at is finding elements based on a particular key. What it's not good at is not so good at is all elements. It can do that. It's not too hard. It does not maintain your order though. And then the final one is binary tree, which is actually a sorted data structure. It automatically sorts, and there's many variants of a binary tree. I could do a whole series of lectures on trees only, but what this binary tree does, it is basically maintains sorted data, so sorted in the natural order of the elements, not in the order in which you added things to the collection. An array list is sorted in the order of adding stuff, not sorted in the order of the elements. So in this case, so a binary tree needs your elements to be sortable. They need to have a natural order. Or a sorting function that provides this capability. But the tree keeps things sorted. So if you need something, okay, I need to keep it, when I use it, I need to have it sorted anyway. Binary tree can be a very efficient way of dealing with that. Then interactive applications. So Android applications or things like that are interactive, and one of the key aspects that you need to realize when you're working interactive applications is that you're basically working in an event loop situation. What you're doing is you're dealing with events and triggering events. Whereas if you have a main function where you can just work on the console, you get to control what happens. You say, okay, wait until ask the user for some keyboard input and wait until the keyboard input has arrived, and wait forever if they don't do anything. In an interactive application, you have to be able to handle operating system events, etc., and draw events. You can't just stop the entire execution of the program just because you want some user input. Instead, what you do is you say, okay, give me the next message. That that message then gets processed by some you need to handle with that. Normally what you do is something called a message pump or an event loop. Is basically give me the next message, or wait until I get the next message, execute the message, wait until the next message, execute the message. And there's probably a condition in there, say if I'm not going to stop my program. And good ones will also often have a timeout, so that every once in a while, even if there's no new message, it will stop waiting for a new message. So to say, okay, have I been told to stop? Things like that. This also leads us to the requirement of primacy of control. So the primacy of control is, where is this control? Our UI inverts this control. So the control logic is often, a lot of the logic is also the same. So we have a framework that encompasses that logic, and you then interact, you plug into such a framework. By the way, this is not only in Android, it is even true in JavaScript. Most of the way that HTML controls work is built into the HTML specifications, how events are propagated, etc. It's all specified. Your browser provides that all for you. You just need to handle the events, not figuring out how do I make it sure that this particular element receives the right mouse clicks. So you plug in your own behavior, and there's different ways of plugging in. So like in Android, you have the base class with methods that basically don't do anything, that can be overridden. onCreate is not one of the empty ones, but if you implement it, for example, on size change to handle best way where your the calculation of the different sizes you needed to use to draw your game, when you look at the implementation, on size change is just empty. It doesn't do anything. It's just there so that you can override it and provide and do something if the size of the control changed. There are things that the view actually wants to do when the size changed, but it does not make that public. It doesn't allow you to override that. onCreate is slightly different in that you need to be able to interfere in onCreate, and that's why you actually have to call the parent onCreate, and there's these strong checks to make sure that you do so, and otherwise it crashes. Another way of handling plugin behavior is with listeners, the listener or observer, so the listener pattern. We've done that as well. So if a button is clicked or the game changes, nice bit about listeners is that you can have more than one listener, and the listener does not need to be a subclass of the type. So certain things are easily handled with overriding a method, other ones are better handled with a listener. And there are also in the Android API certain events that you can use either a listener or an override. And there is you can also provide a behavior provider, which is sort of like a listener but a little bit more complex, like the recycler views adapter we talked about last week. Or if we have a for each, we can have an iterable that we use to provide the actual data points. So as a parameter on initialization of whatever thing we need, if it's a function or class. And of course you can also use lambdas to provide this behavior, an inline function, effectively. So for example, how does your game work? We have our view framework that starts with the control, then somehow there has been an onClick. There's a lot of things happening before the game view gets its onClick. Then at some point it gets an onClick event. It says, yes, I want to listen to this. or say then you actually have these gesture detectors that does the translating the raw events into a more understandable thing, because there's two events when you click a mouse. There's the mouse down and the mouse up. And one of the things that the gesture detection does, it just says, okay, I start recording the thing when the mouse is down. And that's why you needed to override the on mouse down function. Say, yes, I am interested. But what it does then is like, okay, later on it says, okay, if the mouse moves, you are also getting an event. But if the mouse up event is not at the same location as the mouse down event, it says this is not a click. It might be a drag, but it's not a click. And it tries to also do things like, okay, it waits a little bit to see if there's a double click, if you had that. Or is it a long click? What's the duration? Although long click works slightly different, it will actually wait until the duration. If the mouse is still down at that duration, it triggers a long click. Because basically, because the way a long click works is that a user just clicks it down until he sees an interaction, and then he releases his finger. The releasing of the finger is actually completely ignored at that point. Anyway, when we press our onClick function, what we are doing is we are playing our token. That will trigger the game change function, a listener in the game view again, which might even ask the game, has it been won? Okay, if it has been won, it might lock the view, so say you cannot change it anymore. It might also be able to do something on clicks. Okay, as the game is finished, don't allow any clicks. You also, independently whether you locked your view, you want to invalidate your the view. So that goes into the view framework. The view framework does something. You don't really know what it does or how it does so. You shouldn't want to know. It's abstracted away. But invalidate is there. It tells the view framework and the framework that at some point it needs to redraw because this view is no longer, the current drawing of the view is no longer valid. Of course, if it's not displaying the view in the first place, it will not redraw it. Only when it's actually being displayed will it redraw. What your game also does is handle the game change in your activity. Your game change activity may say, okay, has the game been won now? In that case, I am showing a congratulations dialogue, which again you do is something you invoke on an activity, and it will cause a dialogue to be shown. But again, that will only happen after you've finished your onClick handler. It will then, when the framework gets control back, it will go to actually go and show the dialogue. So it works all a little bit more complex than you'd think. So the end, you just return from the onClick in your game view, and we then go to the other events and including that. So it gets to do a redraw, showing the dialogue, etc. And of course the view also gives control back to the activity. So, and this is what onDraw does. So it basically, yeah, at some point it will be called, then it will look up the state of the game, uses that state of the game to draw it. Types. A key part of programs are types. Basically, when you want to do anything specifically, you need to define your own types. Data structures require types. You need to be able to say, okay, these things belong together. It is very helpful to also be able to check on a particular type, but you need to say, okay, I want to have something that has these values together, or this is a number, this is a true or false value, a boolean, string, etc. It helps you to understand what is going on and make things work the way you expect them to. And whatever language you use, every value has a type. And in certain cases you can use, if you can actually figure out what the type of the value is, you can use that type to do something different depending on that type. In this case, you do something called 1 or do something called 2, depending on the type. Types can be handled by your language in two different ways. You can do it statically. So if you have all your storage locations, all your temporary locations have an assigned type, there's no need to record the type of every value because you already know the type in your compiler, so you know which function to call because you know what type something is. Of course, that requires the usage of types to be 100% correct. Another part that types can do, another way that you can handle types is dynamically. You record for every value what the type of it is, and then at runtime use that. It also often is combined with something called duck typing, where if you have data structures, rather than requiring the data structure to be of a particular type that is expected, you just delay that by saying, okay, I need to have these functions in that structure or these names of attributes inside the structure, and only when you try to get a value and it's not there, it might crash, or it might say, oh, there's no value there, I'm just giving you a null or an undefined in JavaScript, and happily continue. Happily continue is a relative notion, and it also makes it much harder to have a good confidence in the quality of your code if you have that kind of language behavior. And that's often why you want to enable strict mode, for example in JavaScript, so that it doesn't do that and you get an actual error message rather than it trying to muddle through. Another point is that if you use object orientation with polymorphism, it requires some degree of dynamic typing, but it's still a regulated version of dynamic typing. And in particular, it can still have static checks. Yes, it needs the type information to know which particular function you need of the subclass, or which particular function, each subclass might have its own implementation of it, but you still know that the value, statically that it is of the parent type. Therefore, you can actually do checks. The only way you break that is with typecasts, where you're saying, okay, I know better than the compiler. And sometimes you do because the language doesn't always allow you to express everything. But dynamic typing, so it is a checkable one because the parent class says you must have this function. And every child class will be checked, yes, that it has such a function. And one of the interesting aspects of types is the use of generics. So sometimes you want to say, I want to do something that works with any form of value inside it, but I want to have that type also still be consistent. So generics are basically the way of handling that. You can put the type you use as a parameter to your function or to your class. Or effectively, if you look at computer science, it's called something called a dependent type, but a very limited version of that if you compare it to what you can do in research languages or things like Haskell or something like that. They are much, much more powerful, but more complex to use. So in this case, in the left, you can see an example of what such code would look like in the case of if you do it by hand, so to speak. You have a base list that just takes anything, and the string list hides away this the fact that it actually stores anything and makes the checking work. So this is kind of how it works, but you don't really want to do that for every single type. And you need to do a lot of casts as well. So generics get rid of the casts, get rid of having to have a subclass just to make sure that the parameter types are correct, etc. It gets rid of the need to have a protected do set that is not visible for other things. And it needs to be a do set, not set, because do set, you can't override a function with a more narrow contract, because you need to be able to call the function as use the object as if it's the parent. The parent says any value can be passed in do set, and then the string list says okay, but you can only pass strings. That's not valid. Generics help you to do this. So generics effectively define a family of types rather than a single type, and the way that you have your in-out stuff like that defines how you can actually relate different types in this family. Classes are a particular kind of type, very common obviously in object orientation. They combine a number of different concepts from programming. In particular, they define a data structure. They support modularization. They allow for code visibility, code reuse, and abstraction. So let's go a little bit through those. So data structure is just the ability to create type that holds more than one component value, component data storage location. This particular example uses a Kotlin data class. So data class provides a little bit of extra functionality. So it says, okay, you want to have these parameters, and it provides equals, it provides toString, etc. That comes with some restrictions in terms of what you can inherit or inherit from. But data classes are there. They are a pure data structure. Just put these things together, and that's the structure. Modularization has to do with breaking your code into different parts that don't always give invisibility into everything that's inside them. You can use classes for this as well. Private methods in a class or in its companion are isolated to only that particular class. So it allows you to hide away things that are not necessary and makes it possible to change them without changing users of your type. Anything that is accessible from the outside is likely to be also used by some code somewhere. So how do you deal with this? You hide it away. You make a private method, or you make it protected, or you make it internal, etc. So it allows you to group your stuff and hide stuff away. That also links with abstraction, where you say, okay, I have this type, I have an interface that needs to be provided. For example, we have the empty list function. It returns a list of type T. It doesn't tell you the actual implementation of the list at all. I haven't checked, but there is in Java there's similarly there is the collections.empty list or empty set that do this exactly the same thing. These functions create you an empty thing, but they don't tell you what the implementation type is. It abstracts away that thing. So if something returns a list, and by the way, if you use the list_of function in Kotlin, that's what happens. It looks at the actual data, and if it gets one value, it uses a singleton list. If it gets no value, it uses an empty list. If it gets more than one value, it creates a regular array list kind of thing. But again, that is the current implementation. In the future, it might do something else. So abstraction allows you to kind of hide away those differences and handle things and think in terms of the what does this do rather than how does it do it. That also, if you hide away those things, it allows you to have more code reuse, and that is a key property of what you want to use in all code, including classes. And inheritance in particular allows you to reuse code in a rather elegant way, but not all code reuse should be done through classes. If you have utility functions that don't really need the state, you can just use them in utility functions outside or as extension functions. So object orientation does some part of code reuse, but not all of it. And code visibility goes hand in hand again with modularization and abstraction. It allows you to say, okay, this particular code is not visible from the outside. Not only is the implementation invisible, if you create helper functions or something like that, that's invisible, it can be invisible too. So you reduce the complexity of the interface and allow for future changes. And allow for future changes. It also can help making sure that the class or the module is only used correctly, because the dangerous ways of getting at it are hidden away. You can only do something, you can only change the state of the object through the well-checked functions that are allowed to manipulate them, and they do their checks to make sure that the state of the object stays valid. When we have classes, there's a number of things we want to think about. Classes, things is, for example, the class invariant. We want to make sure that there are some class invariants are those things that are true for every instance of the class. So an instance is, so a class is a type. It's a category of values almost. An instance is a particular value at a particular memory location that lives there. The class invariant should be true for all instances of that implement that particular type. And that allows users of that type to be confident that when they write something, it will actually meet those requirements. There is inheritance is an is-a relationship. So it is a thing. So instead, when you have a has a relationship, it's like, I want to have behavior of this particular type. I want to have a list inside my thing. But has a is an ownership relationship. And you should not express a relationship that is best defined with a has as an inheritance relationship, because an inheritance relationship is actually public. So inheritance means that you must stick to the contract of the parent. The parent has certain properties, it makes certain promises to its users, you must stick to those. Everything that is valid to be done on the parent must be valid to be done on the child. Polymorphism allows you to use different things depending on the runtime type. And one particular thing that is interesting is the idea of an immutable type. Basically, an immutable type is one where the state of the object is not able to change. And technically that should be, if you have other instances that are part of that state, those instances should also be immutable, not able to change. And primitives are not able to change, and Java strings are not able to change either. And a nice bit about an immutable type is that you do not have to worry about threads, because once the object has been created, it's in a fixed state, and the JVM makes some guarantees about construction, and after you finish the constructor, it will not allow access to the object outside of the constructor before the final constructor is finished. You need to be careful with calling things from inside your constructor, because there the guarantee is not there. There are many, many kinds of classes in Kotlin. So conceptually, there is the nested class. So that's a class-ish thing defined inside another class. That gives that nested class a little bit of access to the outer class, to the private members of the outer class. It also gives a kind of, it communicates that this class is related to the outer class. But most of the way nested classes behave like regular classes. An inner class is a form of nested class that actually maintains a link to a specific instance of the outer class. So they are created in the context of an instance of the outer class. You cannot create them independently, which you can with a nested class. An inner class keeps a link to the outer object that it was created with. You can just create it by having an object instance and then the dot inner class type name. Most of the cases, an inner class is created by code in the outer class, and obviously at that point that doesn't matter. You can have open and final classes or closed classes in Kotlin or in Java as well. So a final class, which is mostly the default in Kotlin, except where it is not sensible for it to be the default, like in an abstract class that must have children. So final means that you cannot inherit it. You cannot override a function. So a function can also be final or open. Same way, are you allowed to inherit it, to change its behavior? The idea of having something final by default is that if you want to maintain these invariants, even if some subclass is trying to, might want to do its best to break it, so if it's important that the invariant isn't broken, you need to design for that. If it's final, it cannot be broken that way unless you go hack into the JVM and override that final property. And yes, that is possible. There's a COMSUN unsafe class that gives you all kind of powerful capabilities to do that kind of stuff. Of course, security managers can forbid you to do that as well. And final does it. So an open basically means you are allowed to inherit this. A sealed class is a type that can only have children within the same file. The Kotlin concept. And that allows you to control which children you have, and it therefore also allows you to have an enum that checks for every possible subtype. In the assignment you saw this for the player type. There was a sealed class that had two children, the computer player and the human player. Both of those could be were open, that you could inherit from them, or the computer player was even abstract. It did not have an implementation for its make move function. But because it's sealed, we know that a player is either a computer player or a human player. There's no other subtype of player, thereby making it easy for you to implement the computer player correctly by inheriting from the right class. And for the checks to be valid, to say, okay, I'm a human or a computer, I just make that check and it is going to be valid. It's not going to break. Because normally checking types on things can break if someone creates another subtype. Data class, like I said, is a class that adds some, by default, makes it easy to create data structures basically, and it adds a lot of default methods that you want to do. You can do it all by hand, but data class makes it nice and concise. You can define a data structure on one single line of code rather than many lines. And there are some, if you have a data structure with 4 variable properties, like the address thing I showed you before, if you do it fully, if you implement fully what data class provides in Java, you'd probably need about 150 lines of code, including white space, yes, but way more than you want to have. And it's all boring code and all can be automatically generated as well. Objects, Kotlin has a specific type of class that is a singleton, basically designed for singletons only. So it will create a single instance of that class There's no constructor because it doesn't make sense. It is a type, but it also has an instance. And in particular, an interesting concept that Kotlin has is the companion object. Basically says that for every class, we also have an object that combines it. This replaces what in Java is the static members, so static methods or static fields, etc., that act on the class, so to speak. Companion object is an actual object. There's only one of them, shared by the entire one of them for that particular class. But a companion object can implement interfaces, for example, or it can even inherit classes. Objects can inherit classes or interfaces. You cannot inherit from an object because there's only one instance. You then would be able to create a child of it. No, that doesn't work. An enum class allows you to define a type with a list of instances with each a name, and those instances can have their own overridden implementations as well. This is very close to an object actually, but a bit different. And this maps also with the Java enum. So basically, a key use for here is if you have a limited set of values, you can use an enum class to create that type. You know that only those values will be there. They are named, so much more readable than if you have numbers. And because of the way it is implemented, it is more or less the same efficiency as if you were just using numbers. But it's much more readable. And of course, if you want to use the polymorphism aspect of enums, you can also do that instead, still efficiently. But a difference between an enum and a sealed class, like a sealed class says these are the children, but you can have multiple instances of the same child type, whereas an enum class cannot. But it mirrors very much a sealed class with only object children. So a sealed class can have an object child. Obviously, an object child has only one instance, etc. An abstract class is one where you leave something out. You can create a class and say, okay, my children will have this function, but I don't have it because in my context, if you have a vehicle and you have a drive function, well, you don't know how to drive a generic vehicle. If it's a car, you can do it. If it's a bicycle, you can do it. But for any vehicle in particular, you don't know how to do it. You leave it to the children, the actual instances or the children that says, okay, this is a particular kind of vehicle, to provide that implementation. Finally, we didn't really cover this. There's the annotation class, which is basically like an interface, but for the annotations, it says, okay, you can actually in your code specify values that are attached to certain code elements. And those values are then created to implement the interface of the annotation class. So it's a specialized interface effectively. An interface is basically, it's like an abstract class, but it doesn't provide any implementation. Originally, now you can provide default implementations, but again, it does not have any state. Then, the synchronization of UI and data is a key part when you write UI applications, and there are design patterns that are used to do this. There's a lot of information available on those things. There's books and whatever, and you have whole books about only these, but you will find them when you are doing UI programming, so it's very important to know about it. And of course, there's some bits in the exam about it. So the challenge that is solved is basically how do you keep UI and data storage state consistent? In particular, if you have data storage changed somewhere else on the network, on a server, on the internet, in the cloud, how do you keep that consistent with your UI? There's basically three approaches that I'm covering. First one is model view controller. This is the slightly older version, where you have a model that represents the business model, business logic and data. There's a view that provides the presentation for that. Then there's user interaction through something called a controller. It can sort of be a little bit embedded into the view, but not a lot. And the controller actually then manipulates the model, which then gets an update, updates the view. The nice part of doing this, by the way, is that you know that the model will always be up to date with your view, or if you make a change and you see it in the view, the model will be up to date. The model is going to be the master data. There's no two copies of the data that you need to make sure you remember to synchronize. If the controller changes it and if the view changes, shows your changed code, you know that it must have gone through the model and have updated, or not if it was invalid. So your model can put all the policy of the data. It can also display stuff. In a web context, it's often not. In a remote context, not always good, because it might take a while for this whole loop to run through. Then there is the model view presenter thing, and this has also been designed a little bit more from the perspective, how can we do good UI testing? And the idea of this one is that you have state change events, and you still want to kind of handle so updates in a different way, but instead of having this loop, you have a view that actually receives events and then passes them along to a presenter that again registers to receive those and then forwards the events in the right way to the model. So again, the presenter does not do the actual changing, although it could theoretically go ahead and update the view in between until the model is actually updated. But it acts as a glue between the model and a view that each have their events and handle things. And then this is a quite usable and common approach to use in Android. And an interesting aspect of that is if you have your view separated, you can actually have a model and a presenter and test those outside of a UI context without having to test the view. And you can have multiple views for the same data. And the final one is the model view model, which requires something like data binding to make it work. We've looked at data binding in one of the lectures, so if you're interested, look at that again. But model view model uses this automatic binding to basically link a data structure that represents the interesting state in a way that it needs to be presented, to link that with a view. So the view model and the model are still not the same thing. The view model can adapt things a little bit, says okay, present this with a little bit of more text decorations or something like that, but it is very close to the model, and the view model is then bound to the view that displays it and might update things when and where appropriate. And view model, of course, might make those changes. And again, this is partially for testing purposes. Then we're getting towards the end. We have coroutines. So coroutines are a little bit like threads, but cheaper. Talked about this last week. So they allow you to do many things. So basically allow you to suspend your computation and then pick it up later. You get a continuation, says, okay, finish now this computation. And the compiler does quite some under the water magic to allow that, continue this later to work correctly with the state that was there originally, etc. So, but it doesn't necessarily mean that it's on a UI thread. It actually does more compiler work to not have to have a thread for making that work. And the key feature of what you can do with coroutines is you can write asynchronous code in a synchronous way. When we go back to the UI, we saw, okay, there's this control inversion. There's all these event handlers and stuff like that. if you want to do something logically across multiple event handlers, what you're effectively doing is doing asynchronous programming. Say, okay, when it's ready, call this. Okay, when it's ready, you get an event, it's ready, okay, now do that. That kind of code becomes very, it's easy, it's doable, but it becomes kind of convoluted very quickly and more convoluted than you'd want it to be. So instead, what you can do is you can use a coroutine that allows you to write this in a synchronous way, in an elegant synchronous way. And you can not only use it for multi-threading, but also as an easy approach to create sequences, like we saw. So this is a Kotlin coroutines based way of creating a sequence. So rather than having to enumerate all the values there, we can just have a block that generates our values. We don't need to store it or anything. Use a coroutine that stores the current state. And so it's actually also more efficient than if you store the whole sequence. You could have a sequence that generates an infinite amount of values. If you put sequence yield random.int or next int with a particular value, that would be valid. It would work. Of course, if you then do for each, it will run forever. But if you say, okay, pick the first 20 random values, it would work correctly and it would stop execution at that point. And then the garbage collector would pick it up at some point and get rid of the state. So you just call the yield function to return a particular value. So this is something you can do with coroutines. And there are some functions in coroutines. So there's asynchronous async function that calls, that basically says, okay, do this somehow in the background somewhere, and it returns a deferred value that only if you try to read it will it certainly give you a wait for getting the result. So this is basically the callback stuff. This is what we often call callback hell. You get all these indented event handlers. Yes, you can use a function rather than a lambda to try and make more sense of it, but then you have different functions. You lose the context of what you're doing. You put them all below, and there's a lot of noise in between. There's no clear indication that this actually logically belongs together. So you use lambdas instead. But then you get this, and this indentation and parenthesis hell. And again, it's not very clear. So coroutines allow you to do this. Yes, I've also updated this example in the original slides. So we just make an asynchronous request. When it's ready, we get the intermediate value. We can do this. And the compiler will make sure that this happens exactly as if it was with the callbacks, but does it without us having to write all those callbacks. And then finally, we take the main dispatcher, make sure that this is done on the UI, that update UI is done on the UI thread. There are a few items that were not full topics that I'm going to discuss here. So the concept of syntactic sugar has to do with the fact that the most important thing you do with code is reading, and syntactic sugar allows you to make it easier to read your code. Makes it more natural looking, it's more understandable, less cluttered. Easier to read code to read is easier to understand that it's correct. What is it doing and how is it doing it? It's clearly correct. Syntactic sugar. Unit testing is the ability of saying, okay, we want to be able to test specific elements of code on an individual basis. You get to use normally a testing library that does drive all the testing, and that allows you to also have all these test runners like in Android Studio or IntelliJ or even Gradle. For those of you who have figured it out, I added a configuration into the assignment code that would actually run the test runner on your code to So run Gradle on your code to check your logic. It would automatically run that as part of Gradle, and it would tell you either that your code failed or passed. But if you looked at the details, if it failed, it would also tell you exactly which tests failed. And that is what unit testing does. So it allows you to test things on a very narrowly grained way, or a little bit more coarse as some part of the testing when I was looking at the moves and stuff like that. Okay, if I play a whole game, does that work correctly, etc. Does it work, and etc. But there's many more. Parentheses are effectively an operator. Not is an operator. In Java, there's something called a ternary operator, the question mark colon thing. Kotlin doesn't have that. It uses if-else expressions instead. The operator basically takes an operand, which is basically the thing that you're operating on, combines that with, if it's not a unary expression, another operand expression. So those both expressions are evaluated, and then you combine them into a result, and that becomes a new expression or a new value. An expression is a piece of code that has a value as a result. So a function call is effectively also kind of like an expression. Although you don't often call it an expression, but yes, in Kotlin overloading, you can override the invoke method on an object, and that makes your object behave like it has a function call operator. So you can call a function on it, even if it's an object rather than a function. The operator overloading is basically giving multiple meanings to the same thing. Basically, what it effectively means is that you look at the type and say, okay, if it's this type, do this. If it's that type, do that. Not a reason why you need types. Addition for an integer is implemented differently from addition from a double or floating point number. They work very differently underwater for a computer. And addition to a string might actually mean that you're concatenating two strings rather than doing math of the individual characters and then doing some really, really weird stuff. And you can define your own types as well. And in Kotlin, you can only do it on a fixed set of operators, in particular because most languages, including Kotlin, actually implement operator priority, so that multiplication goes over addition and stuff like that. Obviously, if you have custom operators, it is much harder to make that work. What is the priority of this custom operator? Well, I don't know. You can use parentheses, but that becomes a bit ugly as well. So Kotlin has not implemented custom operators at this point. And a key thing you want to do also with operators is make sure that you stay sensible with this. Custom operators make sure that, so you want to be normally staying within the intended meaning of that operator. Not always, but mostly you want to do that, so that it becomes easy to understand what is going on. Don't have surprising code. In Kotlin, you organize your code. So Kotlin actually, as the language, adds modules as a key part of the language. You can actually have internal type that is for a module, internal visibility that makes it visible within that module. But and packages are kind of delegated in Kotlin. They mainly do namespaces. In Java, packages are more important, but they don't isolate properly unless you're using the Java 9 plus Jigsaw modules, where you can actually restrict a particular module or a particular package to a particular module, and others cannot override that. So, but Kotlin doesn't really do too much with Jigsaw, although it does kind of work sort of. nested functions are even invisible to functions inside the same file or same class, only within the function that they are defined in. So you can narrow it down, and not only do you hide it, you also hide any complexity. If it's not possible to access the function, you don't need to worry about, do I need to use that one? Then there is something that Kotlin allows you to do very well, is domain-specific languages. Those are languages designed to solve a very particular problem. And an interesting thing you can do in Kotlin is you can make a library that almost functions looks like it's a domain-specific language, so it kind of can wrap around the HTML language, make it feel almost like HTML, but be valid Kotlin, therefore being checked by the compiler for correctness, being able to allow your code to inspect stuff, to manipulate it. You can put logic in there, etc. So you can maintain type safety, you can have completion, and you don't need to do code generation either, because you can do that as well. Although there is some limits in code generation with those languages, because most of the you often end up doing the execution at runtime rather than at compile time. Then the final part of today's revision lecture is the design patterns. So there were 9 design patterns that we covered, starting with the singleton pattern. So the singleton pattern is basically a pattern where you have objects where you only have ever one instance. Sometimes this is a dangerous thing to do. If they don't have a state that changes, it's fine. But you're effectively creating something that is a global variable. It is, and what is the problem with global variables? If they are variable rather than constant, they can be changed from anywhere in your program. If you change state anywhere in your program to any place where it uses this value, suddenly changes as well. So it becomes very easy to change state in an unpredictable way, and it becomes very hard to deal with this. But there are cases where singleton patterns come in. In particular, say, okay, I want to cache some values. I need to have something to load these values. Okay. Do I already have a connection to this database? Okay, then return the existing connection. Otherwise, I return create a new thing, and I keep track of the fact that I have this connection. In that case, you're using the state more as a cache, as a temporary memory to optimize stuff, rather than to actually change your behavior. In those cases, it can be a perfectly valid thing to do. Singleton pattern, and in Kotlin you can use the object, an object to implement this. You can also do it by hand, obviously, and it looks like this. So you create an instance inside it with inside a companion. It has a private constructor, so no one can create it. If you want to use it, you just need to get the instance out of the object, etc. Of course, a companion object is also a singleton itself, but let's not go there. So this is how you could implement that, and you can get the next number. Of course, if you now rely on the value of that next number, you're going to be struggling with, oh, is there something else now that calls this? Or you can even depend on the way that the JVM, the order in which the JVM initializes your classes might, if your class loading or constructor calls a get next number, then you're going to be dependent on the order in which that happens, and you really don't want to have that in your the observer pattern. So the observer pattern is a pattern that basically allows you to register events. So you can attach yourself to something that can be observed, and when the observable changes, it will notify the observers in particular. So an example of here is the notify function that does this, that for each observer calls the update function. So you have an interface, what does an observer need to look like, and then you can have an implementation of such an observer that, let's say, prints updated once it's there, and this is how you use that. The iterator pattern is the pattern of allowing you to get every element in a container or a data structure of some sort, and it will just get through all of them. You don't care about how it works underwater, how you get those elements. It will just give you a range of elements. By the way, there's more than one ways of doing iterators. If you look at C++, they use iterators in a very different way, where they have a begin and an end one, and you say, okay, you're at the end of the iterator if you're at the end. And it allows some interesting concepts that Java iterators do not. In particular, you can use iterators to point to a particular location where you found an element. Java doesn't do that. Composite pattern is where you have a type that contains a container that contains children of its own parent type. So a composable interface might have a composite type that has a list of composables, and itself is also composable, and then you can do something for each of those, and when you need to do something for the composite, it will do it for each of the children. Example of this is, for example, the view group in Android, where you can, when you call the onDraw, or when the view group is drawn, it will draw all its children. When it lays itself out, it lays out all its children first, and then it lays it out itself. So you can compose in that way. Builder pattern is a way of handling the creation of complex objects that have some sort of data structure issue. So that may not be easy to create through a constructor. A builder allows you to do that. It might also be able to say, okay, you have an immutable instance, but the builder has mutable arguments, and you can set it up. And when you build it, it might do some checking and things. But in particular, it handles the case where you have error-prone things with functions with many arguments, or especially constructors with many arguments. And Kotlin makes this slightly less important because you can have named parameters. So if you have a number of the same parameters, if you don't have names, it becomes very easy to don't or not order them correctly. Lazy initialization. In some cases, it is a good optimization of not determining the value of a property immediately, but only when you're first using it. In other cases, it is actually necessary to do so. For example, in the case where you'd say, okay, if you have, you could have used lazy initialization in your assignment when you have lines and boxes. So the lines adjacent boxes needs a box. A box needs a neighboring line, and they refer to each other. So you cannot, when you construct your line, the boxes might not exist yet, because the box might just have asked to create that line, but it's not created itself yet. Or another box might have started to create that line. So if you actually calculate it lazily, the boxes exist, just the parameters don't exist. So there's many cases where you might want to lazily do something. You can do it by hand, as I show here. You can say, okay, we give it a temporary value, and in your getter then say, okay, if it's an invalid, if it's a temporary value, I'm now giving it the actual value. Of course, it would not be a literal, but would be something you calculate or retrieve somehow, and then you return that value. This is a very naive, simple implementation. If you look at the implementation of the lazy object in Kotlin, it is actually a bit more advanced, including safe in multi-threading context, which this pattern is not. So lazy initialization is a common thing to do. Factory pattern. Sometimes you don't want to create instances by hand, but you just want to give me an instance of this particular interface rather than create an instance of a particular class. In the assignment, you'd had the mutable mutable matrix or mutable sparse matrix functions that would create you those and initialize them correctly. So you cannot do that initialization in the constructor because constructors cannot be inline, and the initialization needs to be inline a little bit to make it work correctly. Therefore, we have a factory that does this. In Kotlin, you can even give that factory the same name as the class and make it work transparently. There's other reasons why you might want a factory. So the type can be actually hidden from your users. You have an empty list. You don't care about what is used to create it. Often it's used to also reuse an instance of an empty list, because an empty list is an empty list. Any empty list is the same. So you want to have something. If you want to create an interface of type result type, you can then say, okay, create the result type function that will actually give you the implementation. The implementation can be private to the file that provides the factory. In this case, it's not, but it could be. And then when you use it, you just get an instance of a result type interface by calling the function. You don't get to decide the implementation. Factories are quite common. The adapter pattern is basically when you have one interface, an object with one interface, and you want to behave like another interface or fit into a certain API that needs a certain interface. In this case, we're adapting to strings. But if you use a recycler view, you can have an interface that adapts into a list of items. And this is another version, an extension upon that adapter that we discussed, where we actually also create an iterator for that string adapter. So if you have any string adapter, I can actually call the iterator factory function that creates me an iterator for those strings that happens to be a string adapter iterator that implements has next and next. And because the iterator function is an operator, Kotlin knows to use this if you use a for each. It says, okay, do I have an iterator? Is this iterable? No. Is there an iterator operator for this type? Yes, there is. And it will use this correctly here. And that's one of the tricks you can do with Kotlin. You can get for every element in that thing, do something. The visitor pattern allows you to basically, sometimes you want to do something for each element, maybe even have a visitor could have a return type. So you want to allow people to add functionality in relation to your type, but you cannot do something specifically. You can use the visitor pattern. So your type implements a visit function, and in that visit you invoke the visitor with the right data. In particular, interesting thing is your visitor can actually implement multiple functions depending on different types of data, and then the visited object can call the right one depending on the data it has. So this way you can do something with a complex data structure and use it. And it allows also for something called double dispatch, basically depending on both the type of the object that you're doing it on as well as of the data inside it, where normally you can only dispatch on the object that you're calling it on. And in Kotlin you can even create an extension method that hides away the visitor, that creates the visitor and makes this all work. So you can effectively, you can almost do polymorphism with extension methods using the visitor pattern. So that's the last of the slides for today. Are there any questions at this point? I'll wait a little bit. You're welcome. So this will be recorded, but revision tests. I hope. When will this be available? This week, hopefully. The exam. When will it be? The date I've been given provisionally is the 28th of May. We'll try to also finalize it this week and make sure that I'm not overlapping with anyone else, etc. So the 28th of May is what I've been told what it should be. I've been suggested 10 a.m. I don't really care. How exactly will the exam work? It is a multiple choice test. It will not immediately give you results. The reason why it doesn't immediately give you the results is because I want to be able to actually, when I have to adjust the marks to make sure that it's either not really ridiculously low or ridiculously high. Because we haven't done these tests before yet, that was always the intent anyway, even for the on-paper multiple choice tests. I would look at the results and not necessarily grade it on a curve, but look at it, what would the curve be, and make it something sensible. Just to make sure that the marks are fair and representative. So how will it work? So there will be a time period in which the test is live. Yeah, so I will look at the, basically certain questions might be something that everyone gets wrong or everyone gets right, and I will adjust a little bit if necessary. But if I give you the mark immediately, I cannot do that. So that's how I do it. But let's say my hope is that I can just use the marks as is. But I don't. Yeah, I'm not sure how it will work. So it's online. It's just multiple choice. You will get a time period. We should do 1.5 hours as originally planned. That should be more than plenty for 30 questions. And you will get, it's a bright space multiple choice test. We don't expect to be able to stop you to read the books or the slides, but remember there's quite a lot of it. So if you do have to look everything up, you might be running out of time. There are also questions there that are not so, they are more about thinking about what does this mean rather than that there is explicit explanation. And of course, video lectures. You cannot go and watch the video lecture for the right answer fast enough. That's just not going to work. Results for the coursework. So they have, we've been given 4 weeks rather than 3 weeks. I haven't started on marking things, but yes, the result for the coursework will be after the 28th, so after the exam. Probably. Again, this is a new setup for the coursework, so I need to still figure out exactly what the best way of marking it is. I hope it will work well, but again, it's new, there's less experience, but we've done some things that hopefully makes the marking load lower, therefore makes it faster to mark it. And when we are ready and when it has been QA'd, we will release it as soon as. But hopefully we can do it quickly, for example, through your videos. Placements. Oh, yes, at this point, for placements, I would hope that everyone still has a placement or can get a placement, but I do know that some companies just canceled placements. At this point, the best way of handling the finances part of that, I would say the best place to ask there is Ask BU or the placement office. Because I don't know what the thing is. You can also you can get a placement until quite late, because so you only need 30 weeks of placement. So as long as you can do 30 weeks until before the next term starts in basically end of September 2021, then it's valid. Of course, the question is, can you get a placement? There should still be placements out there. Some companies might actually be jumping for people. Other companies are not. But there's a lot of uncertainty going around. Might very well be that next month there's a lot more clarity. I don't know about student finance. I don't deal with that. So try to call Ask BU. They might very well know about this, or the placement office. At the same time, yeah, so most of our placements are paid. They don't have to be paid. You're even in your placement year, you are eligible for student finance. Let's say if you get paid for a placement and you did get student finance, you might just save it up and use it to pay it off. Or say, I would say but again, I don't really know too much, but I would say apply, and if you then actually don't need it, just decline it or suspend your student finance. So you get it, but you then say, okay, I actually don't need it because I've got a placement. I would go about it that way. If you can't decline it when you don't need it, save it up and pay off your loan immediately when you get the opportunity with that saving. And that's the way I would do it. But yeah, probably want to apply for it anyway, so that you have something to live on if the placement doesn't go on. Because I have heard also about job offers or placements being cancelled. Hopefully none of you have that issue. Any other questions? Okay, then I wish everyone the best of luck with the exam. We will be around still in virtual P201. If there's any, and Piazza, if there's any questions that need an explanation, I will still, if necessary, create a video for that. But otherwise, it's the last lecture of this unit, so it has been a bit strange with this online and offline things. I have some nice videos for next year I can just reuse, hopefully. And otherwise, yeah, just remember that code so that videos are not a substitute for reading. How are we going to implement the no detriment policy? That depends a little bit on your specific circumstances. The biggest challenge with the no detriment policy is that it says, okay, if there is already assessment that the policy says if there is assessment that shows your ability and you then cannot do other assessment, we can use the original one. To me, what I do is to say, okay, if you have circumstances, and I ask everyone who has that to fill out circumstances for this. If you don't have a computer that can do the coursework, for example, we might ask you to do only the logic bit if Android's too heavy but the rest works. If you don't have a computer at all, and unfortunately there are some cases of those, or people whose computers have broken, in those cases you might do some pseudocode instead, or at some point, so we'll try to find a fair solution specific to the students, but there's no blanket, this is how it works for everyone. We look at what are your circumstances, how can we treat this in a fair way. That's how we're going to do this. But it's not going to be only up to me, it's also going to be up to the exam board that in the end finalizes and decides your marks. So that is the no deterrent policy. So yeah, we'll try to do it. If necessary, we'll offer you a pass mark as the policy offers. I would say the exam, try to take it. It might be some resubmission as well, but we understand how that works. Yeah, we're trying to be flexible, and we can be, but we need to know your circumstances to do that. So put in the circumstances form if you have circumstances, including weak or dodgy equipment. And from my perspective, if there is sufficient reason and you couldn't do the Android part, I'm very happy to only give you a mark on the logic part only in those cases, because the logic part is much less heavy. Technically, you could do it even with a web browser, but that is asking for pain. Any other questions? Okay, that leaves me to wish you the best of luck for your exam. And for those of you who finish your assignment, we will be there to answer your questions and help you get along still, for those who have some extension. And see you hopefully next year or in 2 years' time. So for those who still manage to get a placement, and hopefully that's a lot of you, because programming is practice, and the best practice you can get for programming is in a business context, not in an academic university context. So thank you, and see you around, and the best of luck with your exams and your other units.